Now there's a couple of kinds of interest rates that we'll deal with a lot, really three kinds, but two primary kinds. And the first type of interest rate is called a nominal rate. And a nominal rate is an interest rate that's expressed per annum or per year, and it will have a stated compounding period or frequency associated with it. And we denote a nominal interest rate with a small j. So when you see a j, that means it's a nominal rate. It means it's for the whole year. Now, when we have a nominal interest rate, we also have to include the compounding period or frequency associated with it. So you won't ever see a j by itself. It'll be a j1 to indicate it's an annual rate, or a j2, which indicates it's a nominal rate with semi-annual compounding, or a j6 or a j12. It might be a nominal rate with monthly compounding, which would be a j12. So there'll always be those two components. There'll be the j, and there'll be a compounding frequency associated with it. Always has to have those two. So nominal rates are the rates for the whole year, 1 year. The other kind of interest rate is a periodic rate. And a periodic rate is just what it sounds like. It's a rate for one period. And that one period can be a day, it can be a week, it can be a month, it can be a quarter, or it can even be a year. Now, periodic rates are expressed with a small I. So whenever you see a small I, that's a periodic rate. Now, if we have a small I, we also have to say, well, what is the periods? So it'll be I annually, meaning the periods is 1 year. Might be an ISA for semi-annually, 6-month period. Might be an IMO for monthly. So it's a monthly periodic rate, a rate for 1 month. Might be an I daily, a rate for 1 day, and so on. So those are the kinds of interest rates that we'll deal with a lot. Now, there is a third kind of interest rate, which is really just a special case of the first two. The third kind of interest rate is called an effective rate, or an effective annual rate. And an effective annual rate is simply the situation where the nominal rate has one compounding period per year, and the periodic rate has one compounding period per year, so they're the same number. So they're actually the same. So if you see that term effective rate or effective annual interest rate used, that simply means there's one compounding period per year. That's what it means. But we'll look at lots of examples of those. Now, we have to look also at how nominal rates and periodic rates are associated. How are they related to each other? Well, they're very closely related. And they're related to each other by this equation, or relationship. This relationship simply says the nominal rate, the rate for the whole year, is equal to the rate for one of those periods during the year multiplied by the number of those periods. So if we knew what the periodic rate for 1 month is, how many months are there in the year? Well, there's 12 months, of course. So it would be 12 times the monthly rate would give us the nominal rate. So that's how they're related or associated. So in terms of the terminology, this is the equation. So Jm, m stands for the compounding periods within 1 year. So the nominal rate is equal to the periodic rate times m, which is the number of compounding periods within 1 year. We look at an example. Let's look at a J12 example. So we've got J12, so that's a nominal rate with monthly compounding, the rate for the whole year. That's equal to the monthly periodic rate, the rate for one of the months, times the number of months in the year, which is, of course, 12. So that's the relationship. If we put some numbers to it, it said, well, what if I had a periodic monthly rate of 0.8%, and I wanted to find the nominal interest rate? Well, it'd be 0.8% per month, multiplied by 12 months, and that would give me my nominal rate with monthly compounding, in this case equal to 9.6. So that's how I would do that. So we can easily move from periodic rates to nominal rates just by multiplying by the number of periods in the year. If we looked at the same relationship on a timeline, so same type of relationship, this timeline is 1 year. Well, what we would see is we'd have 0.8% in the first month, 0.8% the second month, 0.8% the third month, and so on, all the way up to 12. So the rate for the whole year, the nominal rate, is simply equal to the periodic rates during that year. So we added up all those 0.8%, we'd get 9.6% for the year. So this is the relationship between periodic rates and nominal rates. Nominal rate, the rate for the whole year, is equal to the periodic rate multiplied by the number of periods in the year. In this case, we're using months, so it's 12. But it could be different. You don't have to use months. We could use different time frames. So let's look at some examples. So here's the relationship again. Nominal rate equals the periodic rate times the compounding frequency. Let's get a bit of practice at doing this. So if I gave you some periodic rates and asked you to find the nominal rate, could we do it? Sure we can. Let's look at a periodic rate as an example, a monthly rate of 0.8%. So same as the example we just saw. If I gave you a periodic rate and said, hey, what's the nominal rate? Well, you would know a periodic rate per month is per month. So if we multiply that by 12, there's 12 months in the year, you would get the nominal rate, J12. In this case, again, equal to 9.6%. Now, keep in mind that when we find the nominal rate, it's not any nominal rate. It's only one type of nominal rate. It's J12 in this case. It's J12 because that's what the periods per year were. We multiply by 12, so it's J12. It's not J1 or J2 or anything else. It has to be J12. We looked at another example about a weekly periodic interest rate. Well, if we had a weekly periodic interest rate equal to 0.15, what would we multiply it by to get our nominal rate? Well, it's weekly. We know there's 52 weeks in the year. So we multiply by 52. That should give us a J52. 7.8% in this case. So we can simply multiply the periodic rate by the periods to get the nominal. That's what we're doing. Look at another one. Daily interest rate would be a really small interest rate. So it's a rate for one day. And there's 365 days in the year. So if we wanted to move from a periodic daily rate to a nominal rate with daily compounding, we'd simply multiply by 365. That would give us a J365. And so on. I'm going to do one more. What about if we had a periodic quarterly rate? So this is the rate per one quarter. Well, how many quarters are there in the year? Well, there's 4 quarters in the year. So we take our quarterly rate, multiply by 4, and will give us a J4. So 1.125 times 4 equals 4.5%. So that's our J4. Now we have to know this relationship because when we come to use our financial keys, when we enter interest rate information in your financial keys, this calculator wants nominal interest rates to be entered. So we have to enter a nominal interest rate. But if you notice, some of the questions give you interest rates as periodic rates. So we first have to take our periodic rate, multiply by the periods to get our nominal rate, and then enter it into our calculator. So that's why we have to know this. Now we could also go in the opposite direction because sometimes we might get an answer out of our calculator using the interest rate per year key that gives us an interest rate that's a nominal rate. But the question might ask us to express the final answer as a periodic rate. If that's the case, we have to be able to go the other direction. So what if I gave you a nominal rate, it was J12 equals 10.8%, and said, find the periodic rate. Well, it's a J12 interest rate, so we divide by 12 to get our periods. So 10.8% divided by 12 will give us a monthly periodic rate of 0.9%. If we had a J52 as a nominal interest rate, so that's the interest rate that came out of your calculator. You did a calculation. You got 6.396% as a J52, and I asked you for a weekly periodic rate. Well, it's J52. We divide by 52, get an I weekly. And one last one. What if we got an answer that was a J1? So we've got 9%, 1 period per year is a J1. Well, if we divide 9% by 1 to get the periodic rate, it's still 9. So this is the one situation where the nominal rate, 9%, is exactly the same as the periodic rate, also 9%. And if you recall from our discussion earlier, what did we call that rate? Well, when the nominal rate and the periodic rate are the same, we gave that a special name, called it the effective rate. So the effective rate is a situation where there's one compounding period per year. So you have to be comfortable taking periodic rates, changing them into nominal rates, use those in our calculator, or getting a nominal rate as an answer, and changing it into a periodic rate because that might be what the question is asking us for. It's easy. One simply multiplying by the periods, others dividing by the periods. Nothing too complicated, but something we have to know.